Neuroplasticity is the process by which the brain reorganizes itself and creates lasting change. But what really does this mean, and how does it work?
The basis of the nervous system is the neuron, which is responsible for the transition of information. At resting state, neurons have a difference in charge between the outside and inside of the membrane, accomplished by positive ions and negative proteins. This is called a membrane potential, and the neuron is polarized. When a neuron is said to fire, it means the neuron has become depolarized. You can think of a neuron as a domino. When you push a domino, nothing really much happens. But with a bunch of dominoes creating a neural pathway, they collectively send a signal from one point to the next. Get enough dominoes, around 100 billion, making a complicated web of connections, and you have a brain. Now I want you to think of the first time you rode a bike. It probably seemed very difficult, requiring you to coordinate your leg movements, process sensory information like sight, and keep your balance all at the same time. And yet now you can do all this with ease. How? It all has to do with the strength of connections between neurons. Let's say you see a car coming your way and you have to tell your hands to clamp down on the brakes. That signal has to travel from your eyes to the visual cortex, to the cerebellum, and on again to the motor cortex before it's sent off to tell your hands to get clamping. Between these 2 points, there is a complicated web of neural connections, and the most efficient pathways are strengthened. A single neuron has multiple dendrites connecting to neighboring neurons via their axons. It's the combination of all of these neurons firing, creating depolarization in the dendrites, that causes the overall firing to occur. If the presynaptic neuron fires and this contributes to the postsynaptic neuron firing, then that is a useful connection and the synapse is strengthened in a process called long-term potentiation. If the presynaptic neuron fires after the postsynaptic neuron has already had enough depolarization and fired, then that connection isn't useful and the synapse is weakened in a process called long-term depression.
This is called synaptic plasticity, and it's summarized by the Hebb's postulate, which simply put says that neurons that fire together wire together.
This works because at the synaptic level, when a neuron fires, it triggers glutamate to release into the synaptic cleft and bind to AMPA and NMDA receptors on the postsynaptic neuron. We can call these A and N receptors from now on. This causes the A channels to open, allowing sodium to enter the postsynaptic neuron, contributing to that neuron's depolarizing. The N receptor is prevented from opening, however, because of a magnesium blockage. But if the depolarization is strong enough in the dendrite, the positive charge will expel the magnesium, allowing more sodium and calcium ions to flow in. This calcium has everything to do with long-term potentiation and long-term depression. If it fired before, then lots of calcium is able to enter through the N receptors, creating a large concentration. If it fired after, then the postsynaptic neuron is in the process of repolarizing, meaning some of the N receptors are not available to bind to, so less calcium gets in, creating a low concentration. A low concentration of calcium will cause the calcium to bind to an enzyme called phosphatase, which in turn removes A channels, creating long-term depression. If there is a high concentration of calcium, it binds to both phosphatase and kinase enzymes. The kinase enzymes overpower the phosphatase and instead adds more A channels, creating long-term potentiation. So as you practice riding your bike, the more efficient neural pathways fire together, creating a large calcium concentration which adds more AMPA receptors. So the next time you employ that synapse, depolarization occurs more efficiently, increasing the strength of that synapse. Through practice, your brain has strengthened the most essential neural pathways, allowing the different parts of your brain to communicate efficiently. This means that you can coordinate your leg movements, see where you're going, and keep your balance all at the same time. And pretty soon, you're leaving those training wheels behind in the dust. Every time you make a decision or reinforce a habit or try something new, you are strengthening neural connections and degrading old ones. This is at once both empowering and very scary because it means you and you alone have the ability to control how your most powerful organ functions. Neuroplasticity takes the control stick away from evolution and your genetic code and puts it in your very own hands.